Got myself another little toy here. Let me see here where if I can get it to where it's a little less of the sun. I got myself there's a CT right there. I got it hooked up to my compressor, so it is showing that I got up there in the top left is 246 volts. I'm using, it says 1.71 kilowatts, 60 hertz, bottom left. Top right is the current draw. The middle one is kilowatt hours of energy used, and the bottom is the power factor. It's saying I have a 0.98 power factor, which is pretty stinking good, but if you know how power factor works, it makes sense also why you have a capacitor, right? So on inductive loads, which your condenser fan and your compressor are inductive loads, the current is going to lag behind the voltage. Now, that is not the only reason a capacitor is there, but a capacitor does help to bring your power factor up on inductive loads, especially, well, it's obviously only on single phase inductive loads, because the three phase wouldn't have a capacitor. I mean, granted, again, it's not the sole purpose of a capacitor there is just to increase power factor. It's to get the dang motor going, but that's another story for another day. But I got this this cheap little CT here, and I'm just messing around with it. I guess it's, you can kind of see that. And I'm on the common terminal, which is the sum of the start and the run windings. So you can see, and I'll show you, that 0.98 power factor, that's the common. So that's the inductive part of the run winding and the capacitor part of the start winding. And if we look here on the diagram, black is my common, orange is my start, red is my run. I don't know how I'm going to do this with one hand. Maybe I won't. Yes, I'm not going to, because there's a lot of shit in there that could make me have a really bad day, and it's Sunday and I'm not trying to have a bad day today, or really any day for that matter. So, and yes, my air conditioning panel looks like a Resitex absolute nightmare. You got you got boards, rectifiers, a relay, a transformer, a fan speed controller, I got this off of a 3-phase compressor. It's not really working, but I was just dinking around with it, and haven't got it to work yet. But anyways, got a Copeland CoreSense motor protector, which again doesn't work, so I need to yank that out of there. But yeah, look at this Resi man's nightmare. It's fucking funny. But anyways, I'm gonna stop the video, and then I'm gonna go to the run winding, and I'll show you what the power factor is of just the run winding, which is why these are run capacitors as well, not just start capacitors. It has to do with the overall power factor of the motors. So bring you back in a second here. Okay, so now I am on just the run winding alone, the red wire. Clip through the red wire here. Sorry, the dang sun. Now look at my power factor. 0.58, which is freaking horrible. 5.8 amps of current, 825 watts, still the same 246 and 60 hertz, 193 watt hours. But yeah, there's your power factor right there, 0.57, because the run winding again, is purely inductive. That's why the start winding has the capacitor in it, so that the common, which is the sum of the start and the run, will equal out to, you know, as close to 1, which is called unity, which is a perfect power factor. And it's impossible to have a perfect power factor on an inductive load. You can have it on a resistive load, which means that all the voltage and current that you're paying for, you get to use. On an inductive, that's what power factor is. It's what you draw versus what you get to actually use. The lower the power factor, the shittier your equipment's running. So, yeah, that's on the run winding. Let me see here. The capacitor, this purple, would be for my start. Oh no, orange, right? Yeah, orange, my bad. Orange, right here, is also part of that circuit, and I will put that on the orange wire off going to the compressor, and we'll see what that is. Okay, so this is on the start winding, the orange of my compressor. 0.69. Still the same stuff. 891 watts, 247. And there you can see between the start and the run how you end up getting a better power factor, which should be read on your common, because it is the sum. Again, I'm repeating the same stuff, and sorry for that, but it is the sum of the start and the run. Yeah, man, damn, I gotta clean this thing up. Holy Christ, it looks horrible in here. But anyways, yeah, just messing around. I love to mess around with stuff. So that is pretty much purely the capacitor right now. The in and out of electrons through the cap. 0.7, which, you know, is not good in its own right, but again, it's not measured on just one. It's the sum, which is why I use the black common, and I will go back to that now. And now we are back on the common of the compressor. Basically 1730 something watts. 7.2 amps. Let's see how that is. So compressor RLA 12.8 and I'm at 7.2. Also, it's also not very hot inside, so obviously the compressor is not working very hard. I think it's 60 something, 69, 68 degrees inside my house, so I have basically no load, which is, you know, definitely going to drop your current because your motor's not having to work as hard. But yeah. That is basically what why I bought this, just to mess around, man, just for fun. But anyways, I gotta probably go do some stuff inside the house, and who knows, maybe I'll clean this up and take this damn thing out of here. I can't get it to work since it's 3-phase, and I was hoping to maybe try some wizardry, and I'm not a wizard, so I've come to terms with I can't get the damn thing to work. But whatever, it was worth a shot.